The next challenge was nonces and keys. It says, because of our revolutionary AES-128 OFB technology, we have encrypted your user data so securely that even with the key, and they give us the key, evil hackers can't read out the passwords. And we're given a encrypted SQLite file. So there's two tricks to this problem. The first is knowing that SQLite, the magic bytes for SQLite 3, so the start of the file is actually constant, and it's a constant 16 bytes, which is pretty neat. So this is super useful. AES block mode is 16 bytes, and so we know the first 16 bytes of plain text. So something to keep in mind. They also said that they give us the key, and they're using OFB. So I think this is output feedback. Yep. Cool. So we have the key, we have a plain text, and we have a ciphertext, but we don't know what the IV is. So using this, we can calculate, since we have the ciphertext and the plaintext, we have the plaintext because we know the first 16 bytes. We can calculate to this point because we just do the reverse XOR of here. We don't actually have a way to reverse this one. If we look at the decryption is still using encryption. So there's no way for us to go up and recover the original IV, but we don't actually care what the original IV is. If we look at what happens at encryption, we know what the value is at this point. It's actually fed as the IV into the next round. And so since we don't really care what this initial IV is, and we don't really care about, we already know what the first 16 bytes of the plaintext are, we just skip that original 16 bytes and we just move on to the next 16 bytes, and we are able to decrypt the entire rest of the ciphertext, the SQLite file. So let's take a look at the solution. It's here. So like I said, they give us the key bytes, just 1 through 37 over and over. We have the ciphertext, which is a encrypted SQLite file. And we have the magic bytes. These are the bytes that are at the start of every single SQLite 3 file. Cool. Like I said, we're able, I shouldn't call this IV. Technically, this is the encrypted IV. Actually, I'll call it encrypted IV. So, like if we go back to the demo, the encrypted IV is the thing that comes out right here. So it's going to be the XOR of the plaintext, the first 16 bytes, and the first 16 bytes here. And so we'll have the encrypted IV, and then that's going to be fed into the rest. So we're able to calculate it by just doing a little XOR. We'll XOR, make sure it's 16 bytes. We don't care about the first 16 bytes of the ciphertext, so we're going to move on to the next part. So right here we're doing decryption, which is actually still encryption, and we're right here. We're going to feed it that IV. We know what the key is, 1 through 7, and we know what the ciphertext is. So at this point we can just start decrypting, and we'll get back the plaintext, and we'll feed the output into the next block, and so on and so on. And we'll do that. We'll construct a new cipher object, and we're just going to decrypt the entire flag, and we'll get out this plaintext. So if we do Python 3, solve, see what it looks like, we get a bunch of stuff. But if you actually just look through the file, I think what I did, oh there, I just saw it. You can cat it out and then just grep it, but you can see it's right here. IRS gotta love, is that stream ciphers? And there's the flag.